Hello and welcome to today's video. I am going to be teaching us about the gamma of negative half integers. Now in the last class we learned about the gamma of positive half integers. We devised a formula, if you can remember, that gamma of n over 2 is given to me as root pi divided by 2 raised to the power of n minus 1 over 2, then multiplied by the product operator in mathematics as pi from I equal to 0 to n minus 3 over 2, then you have 2I plus 1. So this formula is valid and it works best when you have your n greater than or equal to 5. So and the condition is that you should know the gamma of what 3 over 2 and gamma of 1 over 2, which respectively is root pi over 2 and root pi. Okay, so that's about this formula. So we are going to learn about the gamma of negative half integers. So what do I mean by negative half integers? So by negative half integers, so we are talking of the like of, we have minus 1 over 2, minus 3 over 2, minus 5 over 2, and minus what? 7 over 2, then etc. And so on and so forth. So let's start with the gamma of minus 1 over 2. What is gamma of minus 1 over 2? So the recursive relation that we are going to use is this one. The gamma of n plus 1 is equal to n gamma of what? N. Now, to make things simpler for us, we are going to make gamma of n the subject of the formula. So gamma of n will be gamma of n plus 1 divided by n. So this is the recursive relation that we are using. For negative half integers. So negative half integers will make use of this this one that you can see over here. So let's dive in and see how we resolve it. So for gamma of minus 1 over 2, if you place it into this formula, you're going to get minus 1 over 2 plus 1 divided by minus 1 over 2. Okay, so you now have the gamma of minus 1 over 2 plus 1 is 1 over 2 divided by minus 1 over 2. And ultimately, this is root pi all over minus 1 over 2. So that is the answer for gamma of minus 1 over 2. Of course, we can express it in a good form, but I'm going to leave it like this for now. So let's go to gamma of minus 3 over 2. Gamma of minus 3 over 2 will be gamma of minus 3 over 2 plus 1 divided by minus 3 over 2 according to this recurrence relation over here. So you are now going to have minus 3 over 2 plus 1 is gamma of minus 1 over 2 divided by negative 3 over 2. We already have an expression for gamma of minus 1 over 2, and if you join it with what you have here, you're going to get root pi divided by negative 3 over 2, then negative 1 over 2. So where this over this is the gamma of what? Minus 1 over 2. So let's go to the next one. Gamma of minus 5 over 2 is going to be gamma of minus 5 over 2 plus 1 divided by minus 5 over 2. And this evaluates to gamma of minus 3 over 2 divided by minus 5 over 2. So definitely this is the gamma of negative 3 over 2, and this is root pi all over, starts with minus 5 over 2, then minus 3 over 2, then minus 1 over 2. Is that okay? So this is what you get. So you can guess what gamma of minus 7 over 2 will be. It's going to be root pi all over, just the pattern. So we'll have minus 7 over 2, then we'll now repeat the remaining ones. Minus 5 over 2, minus 3 over 2, minus 1 over 2. So let's go to gamma of minus 9 over 2 will be root pi all over minus 9 over 2 minus 7 over 2 minus 3 over 2 and minus 1 over 2. Okay, so let's do the last one, which is gamma of 11 over 2 minus 11 over 2 will be root pi, and we now have negative 11 over 2, negative 9 over 2, negative 7 over 2, and I missed negative 5, negative 3, and negative 1 over 2 here. So thank you for that observation. Negative 5 over 2, negative 3 over 2, and negative 1 over 2. Okay, so what do you observe for gamma of negative half integers? Then root pi is always in the denominator, so let's generalize it. Root pi is always on the numerator. Okay, then you now have all odd numbers from n itself. Okay, from n itself, so all the odd numbers from n down to 1. So I have all odd numbers from n down to 1, so I have an n multiplying, so leave the negative sign for now, so multiplying an n minus 2, that's after n, then the odd number before it, and the odd number again following in that order, n minus 4, n minus 6, until you get to 3 times 1. Is that okay? That's 3 times 1. Remember, you're dividing this by 2 raised to the power of the number of odd numbers, okay, between the given odd number and 1 itself. So we are including the odd number itself. So unlike positive half integers where we didn't include the odd number that we are dealing with, in negative half integers we are including it. So between 11 and 1 there are 6 odd numbers, 1 2 3 4 5 6. So 11 is very close to 12. So if I can add 1 to 11, I'll have 12, and 12 divided by 2 is 6. That means for any n, if I want to get the number of odd numbers between n itself and 1, I just need to do n plus 1 all over 2. Is that okay? And it gives me the number of odd numbers. So 2 times 2 is going to be raised to the power of the number of odd numbers between n and 1. So which in this case of 11 is 2 raised to the power of 6. So it's not just 2 we are dealing with, we are actually dealing with a 1 over 2. Okay, or I can actually, you can transform this negative sign to the denominator. Okay, let me just do it like this. You have 2, 1 2 3 4 5 6, so this is n plus 1 all over 2. So what happens to this negative sign? There are also 6 negative signs, okay, in the case of 11, and it's as if you're multiplying minus 1, or you're raising minus 1 to the same power, n plus 1 over 2. So this is like a general formula for calculating it. So minus 1 raised to the power of 6 for a case of 11, then over 2 raised to the power of 6, then you multiply from 11 down to 1, and everything is still under this numerator of root pi. So I hope we get the pattern now. So this is the first representation of this formula, and this formula is valid for n less than or equal to minus, for n greater than or equal to 1. Sorry about that. So this one is valid for n greater than or equal to 1. So all we are just trying to say is that any n that you're giving, you're going to multiply all odd numbers, okay, all odd numbers from n to 1 itself. So if n is 1, you just need to stop at 1, okay. So you need to stop at 1, then you carry out this particular calculation over here. So let's treat the case when n is equal to 1. So when n is equal to 1, this is how I'm going to tidy it. Minus 1 over 2, I'll have root pi. So all odd numbers between 1 and itself is just 1. So I have minus 1 raised to the power of 1 plus 1 divided by 2 is 2 over 2, which is 1. Then divided by 2 raised to the power of still 1. Is that okay? So what I have is root pi all over minus 1 raised to the power of 1 is minus 1. Minus 1 times 1 is still minus 1 over 2. Okay, so this is still in line with what we got up here for gamma of minus 1 over 2. Is that okay? So it gives you, when you simplify it, these two can go up and it gives you what? Minus 2 root pi. Is that okay? So I'm going to modify this formula. We're going to touch this formula up like we did in the previous video, and this is how we are going to do that. So we are going to now say that gamma of negative n over 2 is still the same thing as you having. Okay, so you have, now I want us to know something, that according to this formula over here, I have root pi divided by and this whole product. Okay, I'm going to apply some laws of indices to resolve it like this. So just follow me as I walk us through how I'm going to apply it. So I have this formula as root pi divided by, you now have minus 1 raised to the power of n plus 1 over 2. Then you have n times n minus 2 up to 3, then 1, then divided by 2 raised to the power of n plus 1 over 2. So you need to know that when you have 1 divided by a over b, it's still the same thing as this b coming up. You have b all over a times 1, it's still the same thing. So this 2 that is in the lowest part of this fraction will come up to the denominator position. So this is still the same thing as 2 raised to the power of n plus 1 over 2. And you now have root pi, and all over you have minus 1 to the n plus 1 over 2. Then you now have what? Your odd numbers, the product of your odd numbers up to 3, then 1. Okay, so if you have it like this, you can write your gamma of negative n over 2 in this form. Law of indices, a raised to the power of n divided by b raised to the power of n is still a over b raised to the power of n. If you observe, 2 and minus 1 share the same power, so it will now be 2 all over minus 1 raised to the power of n plus 1 over 2. Then you now have root pi, and all over you have n minus 2, n minus 4 up to 3, then 1. Is that okay? So this formula finally can be written in this form: minus 2 raised to the power of n plus 1 over 2 root pi over the product of odd numbers, which is n minus 2, n minus 4, and 3, and 1. And if we remember the general representation of odd numbers, you can still classify these as negative 2 raised to the power of, sorry, this one is too big, minus 2 raised to the power of n plus 1 over 2. Then I have my root pi, then divided by pi of, I have I equal to 0, then down to, so in this place what I'm conscious about is asking myself how many odd numbers are between what? N and 1. So the number of odd numbers between n and 1 is actually what? N plus 1 over 2. So that gives me, for instance, in the case of 11, it will give me 6 odd numbers. That's 11 plus 1 over 2 is equal to 6. So I want my I to run from 0 to 5. Okay, I want my I to run from 0 to 5. So why is I running from 0 to 5? Because from 0 to 5 you have 6 characters. So how do we get 5 from this formula? If the n minus 1 over 2 gives me 6, that means if n plus 1 over 2 gives me 6, then n plus 1 over 2 minus 1 will give me 5. That's 11 plus 1 over 2 is 6, and 6 minus 1 is 5. So if you solve this, n plus 1 all over 2 minus 2 over 2 is n minus 1 over 2. So this formula should run from I equal to 0 to I equal to we have n minus 1 over 2. Okay, so this is your 2i plus 1. So this is the general formula for evaluating the gamma of negative numbers. So we are going to test it out. Is that okay? So that it will be legit. So let me write it again. So you have gamma of n over 2 minus is given to us as negative 2 raised to the power of n plus 1 over 2, and we now have root pi, then all over we have the product operator I equal to 0, then we have n minus 1 all over 2, and we now have 2i plus 1. Is that okay? So let's test it. So this formula is valid according to what I can see. I think it should be valid for n greater than or equal to 3. So it's valid for n is greater than or equal to 3. So this is the condition where I'll encourage you to use this formula. So according to my observations, it's valid for n equal to 3. So we are going to test. Let's test for gamma of minus 11 over 2. So to test for gamma of minus 11 over 2 with this formula, so the formula is given to me as gamma of n minus n over 2 is, let me just, I like writing the formula, so the more you write it, the more it sticks to you. So n plus 1 over 2, then root pi divided by pi from I equal to 0 to n minus 1 over 2, and you now have 2i plus 1. So this pi that you're seeing here is not the same as the pi that you know. Actually, they are sharing the same Greek symbol, but in this context, in the denominator, it stands for product operator. So we have the sigma for summation. Okay, you know how to use sigma, then this one is for product. So pi is for product, while sigma is for summation. So let's test it on 11 over 2. So gamma of negative 11 over 2 is going to be what? In this case, I'll have minus 2 raised to the power of 11 plus 1 is 12 divided by 2 is 6. So 2 negative 2 raised to the power of 6 root pi divided by, and I have pi from I equal to 0 to I equal to 11 minus 1, 10 divided by 2 is 5. So 0 to 5 is 6. It makes sense. So you now have 2i plus 1. So if we evaluate this, we'll have negative 2 to the 6 root pi. And it's still the same thing as you having, so the product, okay? The product operator will operate for I equal to 0, 1, 2, 3, 4, and 5. So 6 terms. So when I is 0, I'll have 2 into 0, which is 0 plus 1, which is 1. Then the next one will be when I is 1, 2 times 1 plus 1 is 3. So literally for 2, I will have 5. Then for 3, I'll have 7. Then for 4, I'll have 9. And for 5, I'll have 11. Is that okay? So you can see that we have in the denominator the product of all the odd numbers. And if I simplify this thing, I don't mean to simplify it further, but I just want to show you that this formula is authentic. If I simplify it further, it's still going to, if you divide the numerator and the denominator by negative 2 raised to the power of 6, it's still this 1, 3, 5, 7, 9, 11 divided by negative 2 all raised to the power of 6. So since there are 6 minus 2's multiplying themselves, we can still say root pi all over. So you have minus 11 over 2. We'll take 1 minus 2, then minus 9 over 2, and minus 7 over 2, minus 5 over 2, minus 3 over 2 and minus 1 over 2. So this is gamma of negative 11 over 2. So I'm not saying that anytime you want to solve it, you must go through this approach. You don't need to do all these manipulations. All I just wanted to stress is the fact that this formula is authentic, just like we saw when we were building the gamma of negative functions. This is what we got, okay, when we we're treating gamma of minus 11 over 2. So I have shown you a formula that you can use to actually get it. You understand? So if you can memorize the formula and if you can practice the formula over and over again, once you just apply the formula and once you stop here, you're good to evaluating your answer straightforward to get what you want to get. So for now, let me show you how I'm going to evaluate this answer. If I wanted to evaluate it, I'll just put it into this formula, then I'll use a calculator to actually find the value. So let me toggle the on-screen calculator. So with the on-screen calculator, what I'm trying to solve is I have a fraction. I'm not going to evaluate root pi. Okay. So we'll just evaluate first of all minus 2 raised to the power of 6. And we now have the product of 1 times 2 times 3 times 4. 1 times 3 times 5 times. I'm sorry about that. I have negative 2 to the power of 6, and we have 1 times 3 times 5 times 7 times 9 times 11. So this gives me this answer, 0.006158. Okay, so you could actually leave it like this, 0.006158 root pi. You could leave it like this, or in the options you could see it as 32 root pi. Sorry, not 32. 2 raised to the power of 6 is negative 2 raised to the power of 6 is plus 64 root pi all over 1 times 3 times 5 times 7 times 9 times 11. So 1 times 3 times 5 times 7 times 9 times 11 is 10,395. Okay, so you could leave the answer like this for gamma of negative 11 over 2. You understand, after applying this formula. So that's pretty much it about your gamma functions. So everything is a multiple of root pi, just like we are always trying to say. So this is about gamma functions for positive and negative half integers. So summary, can you write the formulas without looking for positive half integers? The summary is that gamma of n over 2 is given to us as we have root pi n divided by 2 raised to the power of n minus 1 over 2, and we now have the product operator from I equal to 0 to n minus 3 over 2. So you have 2i plus 1 So this is valid for n greater than or equal to 5. Then for negative integers, you have minus n over 2. Gamma of minus n over 2 is minus 2 raised to the power of n plus 1 all over 2. Then you now have root pi divided by the product operator I equal to 0 to n minus 1 all over 2. Is that okay? And we have 2i plus 1. So this is the difference between gamma functions. These are the two formulas that you will use for gamma functions of positive half integers and negative half integers. So thank you for watching this long video. I hope this formula will be useful, and to you, I hope you understood how we built the formula. Please don't forget to like, share and subscribe. Your likes mean a lot, so as you're watching, hit the like button, and don't forget to share to your friends. And in the next class, we are going to be looking at gamma of negative whole integers now. Okay, negative whole integers. So we're going to look at the gamma of 0, gamma of minus 1, gamma of minus 2, gamma of minus 3, and so on and so forth. So in the next class, so we are going to look at the gamma of negative integer. So after that, we will jump into beta functions. So till then, stay blessed. Bye.